Hello everyone. In this next lesson we are going to learn how to graph quadratics in vertex form, and more specifically we're going to figure out what vertex form actually is. We're going to talk about that. So if you have a journal or where you're taking your notes, I'd like you guys to write vertex form. And what we're going to do, it says g of x here, but I'm just going to go ahead and put y equals. Could be, right now that's in function notation. But vertex form, it'll be y equals a parentheses x minus h close parentheses squared plus k. This is vertex form. Do a better job of putting a plus sign. Now, you know the vertex is either going to be the maximum or the minimum in a graph. So if we have a parabola that opens up like this, we know that will be the minimum. It will be the vertex right here. But if it has a maximum, the graph will open down. And right here, this will be known as the maximum. And this right here will be known as the minimum. All right, so the a value controls whether it opens up or down. If it's positive, that means it opens up. That means my a value is simply greater than 0. If it opens down, it means my a value is going to be less than 0. Alright, so in vertex form, the h and the k value represent the x and the y value of the vertex. So, right over here, I'm just going to do a quick little example. It's going to make our problem right here. Say negative 3 over 2. It says x minus 2, close parentheses squared. And just for fun, I'm just going to put plus 0, because I want you guys to see what the h value is, and what the k value is. So in our particular problem right here, we have an h value that is literally equal to the number 2, and we have a k value of 0. Now what does that mean? That means our vertex is going to be at the ordered pair 2, 0. So obviously you have Desmos, you have a graphing calculator, you could graph it, and you can find the vertex that way as well. But just looking at the function, you should be able to identify the vertex. Even though they don't do it, that's the plus 0. So remember, this is the h value, this is the k value. So we're going to go ahead and plot, show you those. That point right there will be right there at a 2. Now we have to find another point to put on the graph. All right, so we got to figure out where is that other point going to be. So what I'm going to do, we have x minus 2 squared, and we already know, put y equals. If I plug in a 2, I get, plug in a 2 right there, I get 0. Because if I plug in a 2, I get 2 minus 2 squared, negative 3 over 2 times 0 squared is just negative 3 over 2 times 0, which just becomes 0. So we know this right here is that's our vertex. Now we've got to figure out another point. So here's my suggestion. Let's go ahead and make the easiest number that we can plug in. What would be the easiest number to plug in for x, in my personal opinion? My personal opinion, the easiest number would be 0. So I'm going to put y equals. But this time, I'm going to plug in a 0 right there. So instead of x minus 2, I'll put 0 minus 2 squared. So we have negative 3 halves. 0 minus 2 is negative 2. Negative 2 times negative 2, or negative 2 squared, becomes a positive 4. And negative 3 times 4 is negative 12. Negative 12 over 2 is negative 6. So when I plug in a 0, I get a negative 6. So I can also plot 0 and a negative 6. So I'm just going to put 0 and negative 6. But remember, you also have Desmos, so you could type in your function right here. You can even type in g of x equals. And you can clearly see we have a 2, 0, and we have a 0, negative 6. You can make a table. You can find your ordered pairs by going into the table. There's a little gear symbol, which allows you to be able to make it into a table. All right. So once you plot it, then you're good to go. All right. Now, if you mess up, you can say, see a step-by-step solution right here. Now, they chose 4, negative 6 as their other point. Okay. So here's their strategy. There's the vertex form. Close that out real quick. They found the vertex to be 2, 0. They said finding another point. Okay. When the equation is given in vertex form, it's usually best to look for another point that is near the vertex. Since the vertex is at 2, let's plug in 4. Now the reason they plugged in 4 into the equation is because of this reason. Whenever you're dividing something by 2, all right, and you know when you square something it becomes a 4, 4 goes into 2. So they chose the number 4 because it was going to be an easy point to plot. Now they plugged in 4, but we didn't plug in 4, we plugged in 0. But you'll notice we still got the same answer. So, go here. All right. Now let me go and close this out. I'll do one more problem before we go on to the next one. Graph in vertex form. Here we go. Let's do this one more time. This one says y equals. So what I'm going to do is I'm going to write vertex form down. You can practice with me. I'm going to write this one directly underneath it. Here we go. Y equals 4, open parentheses, x minus 2, close parentheses squared, minus 6. So the first thing we're going to identify is we're going to identify the vertex. We're going to identify the h and the k value, h and k. So right now, looks like my h value is going to be right there at a 2. And my k value is going to be right there at a negative 6. All right, so I'm going to plot it at 2 and a negative 6. I'll plot it right there. Now, once we do that, we have to find one other point. Like I said, probably the easiest point for me to plug in to find an ordered pair for is 0. When we plug in a 2, we got a negative 6. Now let's just plug in a 0 and see what we get. So right here where the x value is, I'm going to plug in a 0. Zero minus 2 is negative 2. Negative 2 times negative 2 is 4. 4 times 4 is 16. 16 minus 6 is 10. So the other ordered pair I could put a 0 and a 10, which would be right there if they let me. Okay. Now if they don't let me, I could plug in a 1, which is right next to the number 2. I could plug in a 1 or a 3. So in Desmos, we'll go and type it in. Y equals 4 minus 6. You can see the point right here is at 2, negative 6 and 0, 10. You can make a table out of it. So if you plug in a 1, it could be 1 and a negative 2. Now before we move forward, I want you guys to see what happens in the graph when I change that from a negative to a positive. If I change it to a plus 2, now we're at negative 2. But ours was x minus 2. So I want to take a screenshot of this real quick. And then I'll take a screenshot of when I change that to a plus, because I want you guys to see the difference between the two. All right, so right here, when that says x minus 2, you'll notice right there, the graph is right there at a 2. But if it says x plus 2, it's actually at a negative 2. Now, why is that the case? If you're thinking about this, what number would you have to plug in there to make this little middle part, this in the parentheses, equal to 0? You'd have to plug in a negative 2. That's why I put the vertex is at a negative 2. But if you have x minus 2, what number would you have to plug in there to make it equal to 0? A positive 2. Okay, so make sure you know the difference between when your vertex is going to be a negative or a positive. Now our r's, all I'm going to do is I'm going to put 1 point right down here at 2 and a negative 6. And then you can move this dot over. I'm going to put it right up there. Oh, looks like I can't do it all the way up to 10. So what am I going to have to do? I'm going to have to put it down here at a 1 and a negative 2. So I got to move it down to 1 and negative 2 right there. All right, but you can see that it still hits right there at a 10. All right, so on this one, I'm just going to do it real quick. Won't take that long. It says x plus 6. What number would you have to plug in there to make it equal to 0? Negative 6. So I know it's going to be over here at negative 6, 0. The k value is 0. I know it opens down. All right, and if I plug in a just a negative 7 and square it, negative 7 plus 6 is negative 1. Negative 1 squared, we get right down here. But I'll just type it in so you guys can see what I'm doing. And make a table. I have negative 6, there's my 0. Type in negative 7, I'm at negative 1. So all I'm going to use is I'm going to use negative 6, 0, and negative 7, negative 1. So all I did in the graph to find my ordered pair, I knew my vertex was at negative 6, 0, because the number I'd have to plug in there to make that equal to 0 is negative 6, and I knew my k value was 0. Just remember vertex form. It's always helpful just to write out vertex form, so I'm just going to go ahead and write it out one more time so you guys can see your h and your k value. There's your h value, there's your k value. And then the other thing I did right here is right there I plugged in a negative 7 because it's right next to a negative 6, and I got negative 7 plus 6 squared, negative 1 squared. A negative times a negative is a positive, but what's sitting out there waiting for it? A negative 1. So when you plug in a negative 7, you get negative 1, and that's why I plotted that right there. All right. Last thing we're going to talk about is quadratic word problems in vertex form. Quadratic word problems in vertex form. So what we're going to do real quick is we're going to make a graph that represents this problem. We'll do a couple of these and we'll call it a day. So make a graph. And this graph's going to be opening up. The very first thing I'm going to do is we're going to interpret the vertex. Alright, so we're going to interpret the vertex. Right now, if I wrote down vertex form, that's a parentheses x minus h squared plus k. So we're going to find our vertex just by looking right here at this equation. Hopefully you can clearly see that right here it says x minus 60, that says x minus h, so our x value of our vertex is the number 60. And the k value of our vertex is negative 100. Now, what does that mean? That means that it went, if we drew this graph, all right, we would have to draw a graph that goes way down here because it's going below, and then it'll go back up. All right, so it says Ying is a professional deep water free diver. His altitude in meters relative to sea level, X seconds after diving, is modeled by this. What is the lowest altitude that he will reach? Now, the lowest altitude is the lowest point, also known as the minimum. Well, our minimum was at 60, negative 100, which means after 60 seconds, he reached the lowest depth of negative 100 meters. So our answer for this one says, what's the lowest altitude that he will reach? We're going to put negative 100 meters was the lowest altitude. How long did it take him to get there? The answer would be 60 seconds is how long it took him to get there. Now, my suggestion, go ahead and use Desmos to help you out with these so you can kind of see what the graph looks like. So 1 divided by 36, open parentheses, x minus 60. Oh, try that again. We're going to hit squared, minus 100. And you're going to have to zoom out quite a bit. So you're going to have to zoom way down there. There you go. Now you can kind of see it a little bit better. So you can see here's our zeros. All right, there's our y-intercept and a 0. Looks like after 120 seconds, he went back up and reached sea level. All right, so we have 60, negative 100. So after 60 seconds, he reached a depth of negative 100 meters. And that's why the answer is negative 100. Let's do one more. It says a hovercraft takes off from a platform. Oh, it takes off from a platform. That means it's going to be above the ground. Its height is measured right here in meters. X seconds after takeoff is right here. It says how many seconds after takeoff will the hovercraft land on the ground? So I'm going to go ahead and type this into Desmos so we have a nice, neat graph. H of x equals, all right, negative 3x minus 3 squared plus 108. All right, plus 108. All right, let me zoom in a little bit more here. Now I'm going to make our graph settings a little bit neater. All right, so basically what I'm going to do is I'm going to start our x-axis at negative 1. And I'm going to put the y-axis at just 10 so we can see a little bit. It's a little bit better. That's a little bit easier graph to visualize or to see. So here we go. Important points. 0, 81, 3, 108, and 9, 0. These are all very important points. So we're going to talk about these points for our particular problem. So 0, 81, that represents the y-intercept. All right, that's how high off the ground the hovercraft was before it went into the air. 3, 108. So after 3 seconds, it went up to a height of 108 meters. So we call that's our maximum. And then way over here at 9 seconds, we are at 0 meters. It took 9 seconds for it to hit the ground. So what I need you guys to understand is the questions are either going to be asking about, like, what was the height at the time of takeoff? All right, at the time of takeoff, the height was 81 meters at the time of takeoff. Over here, this represents the maximum. How long did it take to reach its maximum height? 3 seconds. What was its maximum height? 108. How long did it take for it to hit the ground? 9 seconds. So what I need you guys to understand is any one of these points they could ask you about. Ours, it says, how many seconds after takeoff will the hovercraft land on the ground? Well, that only took 9 seconds. So you have to know which point they are asking you about. Either they're going to be asking you about the y-intercept, the maximum, or what's known as the 0. Okay? And that's basically it. Hope you have a good day.